going to talk about polynomial long division. There is a reason why we do this.
I was never taught history.
You're going to see it real fast and you're going to be okay. So let's do a quick long division reminder. Here's what we have. Let's say we have 12, or make something divisible by 12. Let's say it's 30, 42, 56. I'm just making something up.
Okay.
And I'm going to divide that by 12.
Yeah.
So,
Except for media license.
so when we do this, we start with the process. And the algorithm for long division really doesn't change for polynomial, but it's very similar. So we check, does 12 go into 3? No! Does 12 go into 30? How many times? 2. So I put a 2 here. 12 times 2 is how much? And then I subtract. 30 subtract 24 gives you how much? 6. Drop the 4 down and you get 64. Now you go 12 into 64. How many times? 5. Very good. So we put a 5 here. 5 times 12 is how much? 60. Good. Subtract it out, you get a 4. Drop the 2. 12 goes into 42. How many times? 3. Very good. Put a 3 up here. 3 times 12 is? 36. Subtract it out, we get a 6. Bring the 5 down again. Hey, look at that, 65. 5, very good. A 60. Bring the 5 and the last 6. And 12 into 56 is going to be a 4. 48. And then you have a remainder of 8. Now, do you remember what you do with your remainder? We put R8, or, remember this? It's 8 twelfths.
Wait, can you do it?
No, we never learned that.
That's what it means.
The only thing I ever remember from one tradition was we made these little sandwich things out of food and I had to eat that first.
Oh, okay. Lori, what do you got?
So you can put R8 or 812?
There's a reason why I'm going to start showing that it's going to be 8 twelfths, because R8 is your remainder, but that remainder is represented, it's a fractional amount of 12. It's 8 twelfths, otherwise known as 2/3. So, yes, ma'am?
So, for any problem, will it be over 12?
Whatever you're dividing by. And it doesn't change when you're dividing by polynomials, and that's where we're getting at. Okay? So, here's what we're going to do. The process for long division doesn't really change when you get to these. Now, the book, everything that I've ever seen in a book, always writes out division problems horizontally. What I want you guys to do is to write them like you would a standardized long division problem by writing out the 2x plus 3 into whatever you're going into. But always check this first. What you're dividing a third degree polynomial. A third degree polynomial can have up to how many terms? 4 of them. Does it have all 4 terms? A third, squared, x, and a constant? Yes. So I don't need to put in a placeholder. Placeholders are key with long division. You have to have them. Here I don't. Same thing with what I'm dividing by. Constant, or I have a constant and the first degree, so this is okay. So I fill it in. 2x cubed minus 7x squared, 17x minus 3. Let's say this didn't have a 17x. I'd have to put in a 0x as a placeholder. That's what I'm getting at. And I have an example of that here in a couple minutes. Okay. So right now I have this all written out. This actually becomes pretty easy because when you did long division, you were kind of guessing how many times something went into it. 4, 3, 5, I don't know. Here what you're doing is that you want to take your outside term, this first part here, and you want to turn it into this part here. How do you turn a 2x into a 2x cubed? multiply it by x squared. So here, Lori, for $1 billion, take a guess where you're going to put in x squared, above which of these four?
The x squared.
Thanks, Lori.
You're welcome.
Jaden, you don't get $1 billion.
I'm going to put the x squared there. I'm always going to place whatever degree I'm starting with above whatever degree is within the polynomial. That's the rule. And now I distribute, just like we did before. X squared times 2x plus 3 is, well, 2x cubed plus 3x squared. Move this out of the way. Just like with long division before, what did we do? We subtracted. We're having two subtraction problems. 2x cubed minus 2x cubed is 0. Negative 7 minus 3 is negative 10 x squared. I'm subtracting each part. Just like you did with regular old long division, you subtracted each time down. I'm doing the same thing, but now with a polynomial instead. This is the reason why I showed you guys adding, subtracting, multiplying polynomials, so you remember how to do that. Because in about 2 weeks or so, we're going to graph rational expressions. And when we graph rational expressions, sometimes they get slant asymptotes. And slant asymptotes are found by polynomial long division. Daniel, you look like it's awful. You have to trust me on this one. It is very simple. It is very procedural. Okay? Now I drop down this again. Now I ask, how do I turn a 2x into a negative 10x squared? What do you multiply 2x by to turn into a negative 10x squared? Very good. Minus 5x. Distribute that negative 5x to both parts here. Negative 10x squared minus 15x. And I subtract them again. Negative 10 minus negative 10 is 0. Negative 17 minus a negative 15 is?
Wait, is it negative 10 minus negative 20? Negative 10 minus negative 10.
Is 0.
Negative 10 plus 10.
What?
It's the same as negative 10 plus 10.
If you can't do this in your head, use your calculator. Yeah, that's okay.
Wait, but where did this?
Where did you get 15x?
I'm taking this again, and I'm multiplying it to these 2 points, these values. Just like we did here. 5 times 12 was 60. 3 times 12 was 36. 5 times 12 was 60. I'm doing the same thing. Okay? And now how do I turn a 2x into a negative 2x?
Negative 1.
Negative 1. And I get negative 2x minus 3. When I subtract those out, what are you left with? 0. Do you have a remainder?
No.
You're done.
Wow.
Yep. That's your answer.
So you subtract everything.
Yep, just like you did with regular division. Regular long division is subtraction, same thing.
I should understand.
That's weird.
Huh?
Alright, so you know. Yeah, some of these can take a little bit of space. Same deal.
Why did this take you so long?
Right off the bat, we have a 4th degree polynomial, which means how many terms should it have? Should have 5, so we got to figure out where we need to put a placeholder. I have x to the 4th, x cubed. I don't have an x squared, so I have to put a 0x. Very good. This is the example where you have to put a placeholder in. Now, one thing to tell you guys, whether it's what you're dividing by, what's on the outside, or what you're dividing into on the inside, either one of those might need a placeholder at some point in time. You have to just read it. And that's why I asked you guys, what's the degree? And you should always have n plus 1 for your terms. Okay? And then you start the process over again. I want to turn the x squared into a 2x to the 4th, which means I multiply that by 2x squared, and above which of these do you think you're going to place it? Right above the x squared, good. Distribute through both or all three terms. 2x to the 4th minus 4x cubed plus 4x squared. And now I have how many subtraction problems? 3. Two minus 2 is gone. 3 minus negative 4 is 7. 0 minus 4 is negative 4. And bring down 5. And then I start over again. Yes, ma'am. Sorry, I didn't catch that. Thank you. I looked over at the, I might have just missed it. This is another one of those things you have to be careful with your signs. Yes, sir?
Look at the, never mind.
Okay. How do you turn an x squared into a 7x cubed? 7x. Your object, guys, your objective, each time to eliminate that first term. That's how you know what the next value is. That's all it is. You just eliminate that first term by subtraction. What was that? Negative 14 and positive 14? Yeah. So negative 4 minus negative 14, 10. That's right, right? Yeah. And then how do you turn an x squared into a 10x squared? Yep, very good. Multiply it by 10. And whatever my sign is, it's positive 10, that's why I'm writing plus 10 up here. It's going to be 10x squared minus 20x plus 20. You'll wind up with a remainder in this case. You have 11x minus 21. Now, when you're dealing with polynomials, we don't just write r 11x minus 21. What we do is we create, just like I did earlier, like the 8/12ths, our final answer actually becomes this. 2x squared plus 7x plus 10 plus 11x minus 21 over x squared minus 2x plus 2. This is what the remainder looks like. It's no different than writing out our remainder before was 8. 8 over 12. In this case, it's just a polynomial. That's all. And what happens is that remainder is actually the slant asymptote if we actually were to graph these two equations, this equation together. Okay. What's that? Not with something this nasty looking, but we will do this with a lot easier values. When we have the ones that we wind up, the one that we graph, a lot of them will be very easy to find zeros for. They'd be able to plot your tail dance and stuff like that, and they'll be able to shift things. You'd be surprised at how it's very procedural. You follow the process. It's pretty but this is a procedure. It's a process. You follow it, and you should get it right. In theory. You should. Big mistake that you'll make is like I did there a second ago, I actually wrote that negative 5x and went through it. Let's say you did that on a test. Let's say you actually wrote from positive 5x, you actually wrote negative 5x just like I did, but you did everything right. Am I going to be really mad at you?
Yes.
No. Because you can do everything right, but miss one little sign value, screw up. Now, if you say 7 plus 2 is 5, that's me.
So would we have to like simplify the remainder?
More often than not, you won't be able to. Okay? I honestly don't think there's very many remainders that you're going to be able to. because it had to be a factorable thing. This means it's not factorable.
So you can't like take the second or put it.
What do you mean, Ari? Guys, hold on. I can't hear.
Wait, so like the remainder's 11 and 10, so you can't take the 2x the negative 2x and the original thing like there. You can't like.
No, because this is the answer right here. I couldn't do that here when I did regular division, 8 over 12. I mean, this case you can write it as, what is it, 2/3. I mean, it's just simplified fraction. I can't, in this case I can't simplify. That's all.
So in this case, you not just keep adding like a 0 at the end.
Yeah. And for what?
Like in long division, they always tell us like if you get an answer, you just add a 0.
Oh, you don't have to do that. Because you stop at your remainder, because there's a reason that's a remainder, because it's the equation of a slant aspect.
Oh, we have to learn how to graph these slanted
Not right yet. We'll graph these later.
Okay.
We're getting there.
Not right yet.
Do this one. Take a minute, do this one. You have a third degree polynomial being divided by a second degree polynomial. So the third degree polynomial should have how many terms? 4. The second degree polynomial should have how many terms? 3. So what has to be in the middle of them? Placeholder. It's just from snapping it in. That's all. Okay. It happens all the time. Okay.
Bet. But you won't.
Okay.
What's one of the best flash? I don't know.
Another little tip I'll tell you guys, space it out a little bit. You got plenty of space. Space it out some. It's not the end of the world. Okay. So how do you turn an x squared into a negative x cubed?
Negative.
Negative x. Where do you think I'm going to put that above? Right. And that's the other thing. Remember, that's what you're always going to place it above. Is it okay that I put -1 there? Habit for me, whenever it's the first term, I usually put a negative. If it's negative, I usually put a 1 just because I don't know why I just do. Distribute that through. We're going to get a negative x cubed plus a 0x squared plus a 1x. You okay with that? I hope.
Yes.
Okay. Subtract everything out. 0, 2x squared, negative 3x, and a 3. How do you turn an x squared into a 2x squared? Multiply by 2.
I really feel
I know, it's like a sound spare, like. You'd be surprised how often I don't understand stuff.
Well, I think I wouldn't use it, but then I could do it.
Also, when you're done, if you're done dividing as soon as what you're left over with is 1 degree less than what you're dividing by, because it can't work. Okay. So my final answer here would be negative 1x plus 2 minus 3x plus 5 over x squared minus 1. And I would be done with that.
We just have it as negative x.
Yes. That's your answer. That's your solution. Okay. So if you were to graph this,
Oh,
what was the original problem?
I don't know.
So it's negative x cubed
plus 2x squared minus 2x.
Hold on. And then what?
Plus 3.
And it's over x squared minus 1?
Yes.
If I graph this,
Oh, I broke the tip.
It looks like a running stick figure, but
you get this graph,
it's not supposed to bend that way.
and notice that you get this part here, 1, 2, 3, 4, 5, down 3, over 1, down 3, over 1, down 3. You get this slant asymptote that'll occur between the two. That's where that comes from.
What's that little thing is small?
There's a reason why that happens, because there's that you have a perfect difference in squares on the bottom, and you have asymptotes here and here because you can't divide by 1 or -1 because it'd be zeros. It's asymptotes. What I want you guys to do are these, and I wanted to stop so you guys had time to write them down or take a picture or whatever if the internet's still out. This is in. I posted it on the calendar, but I don't think it's going to work, so I don't know why. I'm going to figure this out. It's page 356, I believe. Okay. So it's up here right now. If your Chromebook is not allowing you to take a screenshot of it, please take a couple of minutes, write it down, or take a picture of it, text it to somebody, so on. To do what? Yes, ma'am. Yeah, go ahead, Lord. All right. And then on Monday we'll start doing the synthetic division, which basically opens up everything to be able to do.